Thank you. So this is the last talk before lunch, right? So I'll be really quick. Okay. So I'm one of the co-lead on this program with Kenneth, but I'm also heavily involved in Work Package 5 that does the integration of the overall system. And I have expertise in cognitive architecture, so that's why I'm in there. So you can see that I'm trying to integrate everything into this system. And the goal is, of course, the collaborative intelligence. So what is collaborative intelligence? So we have to think about collaboration, right? Collaboration means working with somebody, or in this case, a robot, uh, to do something together, right? And it's not easy. We know that because it requires to have a common goal, and you need to trust each other. I mean, at least up to a certain point where that the other party will do what you think it will do, right? And you need to clarify the roles between you guys. And also you need to communicate effectively to do that. So all these things, like each one of these are pretty hard um, to implement on a robotic system. So, uh, but if you have these, you will have natural interaction with humans, and also you will be able to adjust and adapt to different situations real time. So that's the beauty of it, right? So here's an example for manufacturing scenario, right? So a person can come in and say, okay, help me assemble this gearbox. And the robot, instead of just saying, okay, uh, it can see the situation, right? So the output assembly is heavy. So I'll do that, which means you do the lighter part, right? So which makes sense in this case. And then you can work together. So this will be um, an ideal situation where the robot knows the task and trying to come up with the natural um, assignment of tasks. So some facets of collaborative intelligence, I listed them here. It's not exhaustive, but let's go through this. So we need to understand the situation, right? And you need to know how to do this task, right? It's a gearbox. You need to know how it's assembled, disassembled, and you need to know yourself. You need to know what you are able to do, and you also need to know the counterpart. You need to know what this other person or the robot is able to do or not able to do, and you need to understand the intention, and uh, and you need to be able to explain yourself and learn from the other party if necessary. So what do these translate to? So they translate to something like multimodal perception and being able to infer the situation. You also need to have common sense and as well as the domain specific skills. You need to have meta knowledge about yourself, and you also need to have some sort of theory of this counterpart. And you need to have the capability for intention recognition, language understanding, and sometimes gesture understanding. And you need to be able to generate language or gesture if necessary. And you need to be able to learn from instructions or observations. So when we look at all these capabilities I just talked about, right? So then we could put things together like this, maybe, right? But this is a very fragmented approach to intelligence in general, and in this case, the collaborative intelligence, right? So you have environment and you have a bunch of modules that talks to one another, right? They're all connected, and then somehow they communicate over those channels and do something. But this is not the approach we're taking. So this has bunch of black boxes, right? You never know what the other module is doing. Like you only communicate with these other modules based on whatever definition of communication you have. And whenever you are trying to add a new functionality, you will bring in a new black box and add it in and try to connect it to the other parts. So instead of that, this is what we're trying to do, right? Integrative approach. So we have this base in like this infrastructure, right? So it's sort of like uh, it's very cognitively inspired, right? You have long-term memories and you have short-term memories, and then there are some buffers, right? And then you interact with the environment, right? So we have this basic framework, and what we're adding is new process within this framework. So the reason why we're taking this particular structure is because of what people have done in psychology or cognitive science, right? This is how human intelligence, like general intelligence, seems to work. So we're trying to replicate it in this system. So in this particular case, that framework I'm talking about is the cognitive architecture. And it sort of looks like this right now. So you have long-term memories. Yeah, you have long-term memories here, right? And then you have short-term memories, and there are some buffers attached to those short-term memories. And of course, there are a bunch of processes that goes from one of these boxes, like the memories, and then the other memory. And this whole thing interacts with the environment through these buffers. Now, so for the perception side, we have multimodal perception, right? At least we have two, right? The visual perception and the tactile perception. And we use, sorry. So we use low-level classifiers and language parsers, right? So by using the cognitive architecture, we're not really eliminating all these deep learning based approaches from the picture, right? So we still want to benefit from them, so we still use them here. But in the end, what we get is these higher level information, right? The information about the situation that goes into the cognitive architecture, right? And then we use the inference process afterwards. And then we also have new process that uses the episodic memory, where in general, so it just deposits all information about what's happening around you, right? And then we use that to, for example, match what's happening in the world to whatever you know about this particular task, and figure out where things stand or where this other person is trying to do. And then we also want to add some common sense knowledge, right? So these things would go into the long-term memory of the system, and then we can benefit from that using the processes we already have. And then at the end, we have some multimodal motors, right? So you can talk, you can manipulate something, or other things, right? So we can have these low-level motors that goes back to the environment. Okay, so that will be the overall system after adding all these things. Okay, so let me give you two examples of how we build in the capabilities into this kind of framework, right? So one example is learning from instructions. So what we do here is really revealing what's inside the architecture itself. So the architecture has this problem solving capability in general, right? So what we do is we want to connect its internal processes to the outside world through these dialogue, so that the user can actually access these processes. I mean, user can influence this process. So what happens is the user says something, right, at the very beginning, right? So the system doesn't know what's happening, right? So the system has no goal, and it doesn't know about whatever it is that you're going to do. And then user says something like, let's remove some plugs, right? Then those things become the top level goal of the system, right? At this point, the system might or might not know what that means, okay? And depending on the case, like if there's a knowledge about it or there's no knowledge about it, then it will go down different paths. But basically what's happening is interleaved user instruction and robot execution. So rather than just sitting there doing nothing until the user explains the whole procedure, what happens is that the robot asks for step-by-step instruction. So you get an instruction and the robot does it. And then at the same time, user get to verify whether or not it got it for that step, right? So we go through that. And then based on that episode, the system can learn new concepts and skills. Okay. And then once that's done, the system will, I mean, the user will initialize it, the world, right? You need to put things back to the initial state. And then robot can execute whatever it has learned for verification. So this is the scenario that we are going through in learning from instruction uh, example. So this is how it's done exactly, right? So you can say, let's remove some plugs, and this becomes the top level goal of the system. So the system will automatically translate that into a goal that says plugs removed. Playing, yeah, okay. And then after that, the system doesn't really know what this means, right? So this is an undefined goal. So it's going to ask what it means. Then you say, okay, remove the left plug, right? And then you have this as a sub goal, but then you don't know how to do it, let's say. Then it will ask for another instruction. Then the instruction is like pick up the left plug, which is what the robot is doing right now. Then the robot sees two plugs and it knows what left means, and it will have pick up oil plug one. So it does that. Then once it does that, it just sits and wait for next instruction. And the next instruction was move up, so that's why it went up. And then the next one was discard, so that's why it's doing the discard. Then what's important here is that you went through the process, and then now the system is able to learn this when the user signals that everything is done. Then what happens is that it learns this new procedure for a particular goal of plug removed. So now it learns the procedure for that. And then at the same time, it also learns the end goal. So now it knows what it means to have plugs removed. So it learns new knowledge from this episode. Okay, and the second capability I'm just going to briefly introduce is common sense instruction understanding. So you saw that I'm assuming that the system is able to understand whatever utterance you're giving, right? But it's, typically you cannot just have free dialogue. You have to say certain things, right? You have to use the verb remove or unscrew or things like that. And if you use a very different verb, you might not be able to understand it. But this can solve that problem, right? So we have a common sense knowledge base. I believe there will be another talk about it or a demo outside. So whatever utterance comes in, we can match the verb, the action word, to a specific skill. In the example I showed you, it was able to do that immediately. But sometimes it doesn't know what this verb means. Then it needs to look up this common sense knowledge base to find a match of whatever it knows about. Right? And then you can match that skill and take that as an intention. And you can go off and do whatever you need to do, like the learning from instruction. So that's the prime net. So it's a common sense KB, and most importantly, it provides a hierarchy of entities and concept, and also the action primitive, right? So you can understand. By the way, this is not my work; it's Eric Cambria's work. So it allows you to ground the action word that's used in the instructions, and then you can also suggest the equivalent skill, basically, right? Because remove means pick up, or pick up means remove, or something like that. And let's say you know only one of them in your domain knowledge, then you can map them so that you can use that, and then you can understand the utterance properly and then execute it. So you can take a look at the demo outside later on. So let me summarize. So human machine collaboration is hard, right? But it's useful in many domains. Hopefully we'll find more use cases. Um, so we want to enable machines to adapt to us and our environment, right? Now, we take an integrative approach to that, and we're extending a cognitive architecture. And what it does is that it does this multimodal perception and inference, and it is able to recognize intention and understand plans. And it also has common sense based language understanding. And finally, it can do learning from instructions or observation. So that's what we're trying to do. Not all of these are done, right? For example, we're still working on learning from instructions and observations, and hopefully we'll be able to demonstrate it in the near future. Okay, so that's it. Thank you very much.